Okay, we're going through, I'm just going through all the examples from the assignment that we did. This is just proving the transitive property. So again, remember you can't use the transitive property to prove the transitive property. We've got three angles, and angle A is congruent to angle B. Angle B is congruent to angle C. And we'd like to show that A is also congruent to C. So this has been given. Use the same strategy we were using for the segment, so we'll convert these to measures and use equality. Measure of angle A equals measure of angle B, and the measure of angle B equals the measure of angle C. That's a definition of congruent angles. Now we can just use transitive property. Measure of angle A equals measure of angle C. Transitive property of equality, and since we've set two measures equal, then we can say that the angles are congruent. And that's just the definition of congruent angles. Let's go into our second one here. Okay, so we're given measure of 3 is 40 degrees. And 1 is 2 are congruent, and 2 and 3 are congruent. They want us to show that 1 is also 40. So the measure of angle 3 is 40 degrees. So all that's given. And we've got that transitive property situation. A is congruent to 2 or B, and B is congruent to C, then A is congruent to C. So we can say that angle 1 is congruent to angle 3, transitive property of congruent angles, and therefore the measurement of angle 1 equals the measurement of angle 3 from the definition of congruent angles. And we can substitute in right here. We said that the measure of angle 3 is 40, so the measure of angle 1 equals 40 degrees, and that is substitution. Property of equality. Prove the right angle congruence theorem, so I can't use the theorem. And looks like we're given a couple of right angles. So angle 1 and angle 2 are right angles. They tell us that. Well, I know that measure of angle 1 equals 90 degrees. And the measure of angle 2 equals 90 degrees, because that's the definition of right angles. And A equals to B, B equals to C, so the measure of angle 1 equals the measure of angle 2. Transitive property of equality, and since the measures are equal, the angles are congruent from the definition of congruent angles. So now we can use that property. Prove the congruent supplements theorem. Okay, so that theorem just says that if two angles are supplements with the same angle or congruent angles, then they're also congruent. So they show us that 1 and 2 are supplements, or they add up to 180. 3 and 4 are supplements, they add up to 180, and 1 and 4 are congruent. So let's prove that 2 and 3 are congruent also. So angle 1 and angle 2 are supplements. Angle 3 and angle 4 are supplements. And that's given. Okay, so if they're supplements, then I can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Measure of angle 3 plus the measure of angle 4 equals 180 degrees. That's the definition of supplementary angles. That means these two things are equal to each other. So the measure of angle 1 plus the measure of angle 2 equals measure of angle 3 plus the measure of angle 4. And that's just if A equals B, then B equals C, transitive property. Okay, so that's got us so far. I'd like to get rid of, I want to show the 2 and 3, so I'd like to get rid of 1 and 4. Right here in our given it says that angle 1 is congruent to angle 4. That's given. That means my measure of angle 1 equals my measure of angle 4. And that's a definition of congruent angles. And I can subtract equals from equals. So if I subtract this from both sides, I get measure of angle 2 equals measure of angle 3. So from this side I subtract M1, from this side I subtract the measure of angle 4. That leaves me with two measures that are equal, and that's just the subtraction property of equality. And if the two measures are equal, then the angles are congruent. That's a definition of congruent angles. Oh, these gave me grief last time.